And we're back. Last time, we talked about memory tables and how we can leverage them to keep track and manage all of our variables throughout the lifetime of our program. Today, we're going to have two things in mind. One, how can we expand on some of the types of variables that we've already talked about? And two, we're going to learn about the concept of a variable size. So let's jump over to the iPad and get started. Variable size. A variable size is going to vary purely on its type. It doesn't matter what the value of the variable is. It doesn't matter what the name of the variable is. If you know the type of the variable, you know the size of the variable. So given that, we're going to be adding a new column to our memory table, and it'll look like this. We will have all three of the columns that we're used to having. And then we will add the size column. Now the size column is not going to require you to change your code in any way. All that's going to be is an extra bit of information that you're going to be keeping track of from now on. Every single variable, regardless of what its value is going to have a notion of size. Let's say we look at a number, and we all agree that we're not allowed to have a number that is more than 3 digits long. That means the smallest number we can have is going to be the number 0, and the biggest number we can have is the number 999. If I wanted the number 1000, I could not abide by the previous rules that I had put in place of only allowing for 3 digits. I would need a 4th digit. In fact, if I had the number 1000 and I tried to read it as a 3-digit number, that means I just read the 3 digits that were available to me, I would have the number 0. So this is an example of size. Now, for variable sizes, we use a special unit the computer requires, which is called a byte. So all of your sizes are always going to be bytes. And in today's lecture, we'll just explore the size of various types, and we'll add some more types, but we will not be exploring exactly how these sizes are computed and why they are what they are. For that, you'll have to wait until a future video. So let's go ahead and list out some of the types that we're already familiar with. We're familiar with int, we're familiar with float, we're familiar with character. For integers, I'll inform you that their size is exactly 4 bytes. Floats are also 4 bytes, and characters are 1 byte. You are not allowed to have a size that is a fraction of a byte. All sizes must be whole bytes. You can have a size that is as big as you want for some types, but we won't be going into those either yet. So what this means for size is anytime you declare a variable of type integer, you would simply write 4 in the size column for that variable. If you were to declare a variable of type character, you would simply write a size of 1 for that variable. This will go along with all the other information that we're already used to writing, so make sure you fill out the entire row from now on. If you don't become comfortable with the sizes of these variables, you're going to find it much more difficult in the future lessons. So don't skip the steps and make sure you list out the size of all the variables that you're going to be using in your memory tables from now on. Now, a natural thought process right after we discuss size of a variable is talking about the limits of that variable. So just like we saw, if we use a 3-digit numbering system, we'll be restricted to the numbers 0 to 999. We simply don't have a way to represent 1000. So what that means is, as long as you have a number that is limited in size, you are not able to represent all possible numbers. You always have a minimum and a maximum. Now, floats and characters are a little bit of a special case, so we won't be discussing them too much in this video. Now, the minimum value for an integer goes from negative 2,147,483,648, and the largest integer you're allowed to have is 2,147,483,647. But luckily for you, you don't have to remember it this way. A shortcut to remembering this number is going to be the smallest an integer can be is negative 2 to the power 31, and the largest it can be is 2 to the power 31 minus 1. Don't believe me? Go ahead, plug it into a calculator. you'll find that this should be exactly what it equals. What that means is if you wanted to represent the number 2,147,483,648, you wouldn't be able to, because the largest an integer could be is 1 less than that. However, there is a trick that a lot of programmers are familiar with in order to represent some larger numbers. And that is the notion of telling the computer a little bit of information about what you want and don't want this number to be able to do. For example, what if I didn't care about using any of the negative numbers at all? As in, I knew for sure this number was going to be only positive. Let's say I was counting the number of people that are walking by on the street. It's not possible for there to be negative people walking by. The number of people walking by on the street can only ever be positive. So the notion for that is the idea of describing the signedness of your number to the computer. And we can do that simply by telling our computer whether or not we care about the negatives or we don't. By default, the computer is going to assume we do care about the negatives. So if we explicitly don't care about the negatives, then we want to go ahead and tell the computer we have an unsigned number. We can do this by typing in unsigned int as the entire type. Now before, our type was int. But if we add an unsigned int, it is a different type than using an int. The ranges for the two are also different. The smallest an unsigned int is allowed to be is 0. The largest it can be is 4,294,967,295. Or for short, 0 to 2 to the power 32 minus 1. Now, how I'm able to recall the shortcuts for these numbers, we will get to. But for now, if you ever somehow do write a program that is using this large of a number, be sure to remember that if you go over 2 to the power 32 minus 1, your unsigned int won't be able to represent it correctly. Additionally, if you use an unsigned int type, you are not allowed to use negative numbers. You can still subtract numbers, you just can't ever expect your number to be negative. But now let's get back to the question. Why do we care about the size of variables? Why are we being so pedantic about something like this? One, it's going to help cement a concept that we'll be exploring in the upcoming lessons. Two, these can easily help us find bugs in our code. For example, let's say we were writing a calculator that added in two really large numbers, but the numbers we had summed up to 5 billion. 5 billion is going to be less than the maximum value that both an int can represent and an unsigned int can represent. So we would not get the right answer. However, we wouldn't know that if we didn't know these variables had sizes. And three, for good software design, it's important to think about the context in which a variable will be used. If you know, for example, that you're only going to be counting up to 1,000 things, it seems like a waste to have a number that can represent up to 1 billion. So we have a couple of new types that we're going to introduce as well. So let's go ahead and review really fast. We know we have the following types available to us. We have an integer, we have a float, we have a character. We also know a couple of things about their sizes. And in some cases, we have a minimum and a maximum value. So an integer is 4 bytes. A float is going to be 4 bytes. A character is going to be 1 byte. And we haven't yet been told what the minimum for a float and a minimum for a character is. Similarly, same for the maximum of each of those respectively. But we do know an integer goes from negative 2 to the power 31 all the way to positive 2 to the power 31 minus 1. In addition, I recently introduced a new type, which is called unsigned integer. Notice there is a space between unsigned and int. However, the computer knows that if you've put unsigned, it applies only to the thing right after it. And the size of an unsigned integer is going to be exactly 4 as well. The minimum value will end up being 0, and the maximum value is going to be 2 to the power 32 minus 1. Another type we have available to us is going to be the type bool. A bool can only be 1 byte, and its minimum is going to be 0, and its maximum is going to be 1. So at any point, if you want to represent a concept of just true or false, we will use a bool. A bool is just a split between something that's just absolutely true and absolutely false. A great example for using a boolean would be did rain today. It either did rain today or it didn't. There's no in between. Now, it might have rained a lot, or it might have rained a little, or none at all. But in 2 of those cases, the answer to did it rain today would just be yes, it did. And then we have the type called a short. A short is just 2 bytes, and a short will range from negative 2 to the power 15 all the way to 2 to the power 15 minus 1. And then we have the long type. A long type will be 4 bytes. It ranges from negative 2 to the power 31 all the way to 2 to the power 31 minus 1. And lastly, we have the long type, which is going to be 8 bytes. And you guessed it, it's way smaller. So it goes to negative 2 to the power 63 all the way up to 2 to the power 63 minus 1. Now, in addition to long, and short, we actually are allowed to add unsigned on top of each of these in case we don't care about allowing negative values. So hence we additionally have unsigned short, which is also 2 bytes, but goes from 0 to 2 to the power 16 minus 1. Unsigned long, which is also 4 bytes, but goes from 0 to 2 to the power 32 minus 1. And unsigned long, which is 8 bytes as well, but goes from 0 to 2 to the power 64 minus 1. Now you might have noticed here that I'm allowed to add the word unsigned in front of the short type, the long type, and the long type along with the integer type. So while I have a base type that is int, short, long, I'm additionally allowed to potentially add unsigned in front of it to expand my maximum range while I give up the minimum range. Now, I understand this is a lot to memorize, but as we get more and more familiar with it, it'll just become second nature what the size of a variable is. One of the ways we're going to be practicing this is by continuously writing in our memory tables exactly what the size of every variable we use is. Secondarily, I'm going to make a second request of you. I want you to think carefully about what type of variable you want to use. Is your number allowed to be negative? Should you add unsigned in front of it? Is your number going to be very large? So should you use a bigger type? Is your number going to be very small? Should you consider using a smaller type? And of course, what are you going to do if you forget what these minimum and maximum values are? Well, it's no worries, because the easiest thing you can do is just go back to the assignment that I'm going to give you with this website and just look at the table that is provided. The table will include all of this information, even grouped by the size of various variables. Now, one last thing I want to show you is going to be a little bit of code. Let's say we have a variable, an int specifically, that's named my number, and set the value equal to 15. Now, one thing we can do with this variable, as we all know, is print out my number. And let's add some quick little flavor text. So my number is one other thing we're allowed to do is actually print out the size of the variable on our machine. The size is. We can do this by simply taking advantage of the size of command. The size of command just takes in a variable name and it will simply print out the size of my number. Notice it's only printing it out because it's part of the cout. If I had just written size of on its own, it wouldn't do anything on its own. This statement will not do anything, but as a part of a cout statement, it will print out the size of the myNumber variable right next to the size is. So let's go ahead and try this out. And as you can see, the size of my number is 4. And this size is going to return exactly the size in bytes. Let's say this variable was instead going to be a short type. Does this change anything? And you'll see the size of the variable is now only 2 bytes. Similarly, if I was going to use a long, the size is going to be 8 bytes. And of course, lastly, if I was going to use my regular old int, the size is going to be 4 bytes. Now, just to confirm that if I make this an unsigned int, as it is a positive number, does my size change? Let's find out. Just like we expect, when it's an integer, the size is always just going to be 4, regardless of it's signed or unsigned. The only difference is your unsigned number is not allowed to be negative. I'm sure you have many questions about this lesson, and that's okay. This lesson is a little bit more challenging than the others because unlike others, this one is just going to be a bit of memorization you're going to have to get comfortable with. However, in the future, we'll explore exactly what a byte is, why we have these limits of 2 to the power of something, and how we can naturally think of the limits of these numbers instead of having to memorize a bunch of facts. All this and more coming up next time. See you then. Bye.